Hi, welcome to lesson 5. We're going to solve rational equations literally, meaning that we're going to isolate a particular variable and not worry about what the other variables are. So to get started, let's go ahead and work through this problem, copy it down, and follow the instructions on your own, and then press play to check your work. Right. So the area of a trapezoid, and I've drawn a trapezoid in case you've forgotten what that looks like. And in a trapezoid, I have two parallel sides that we call the bases, base 1 and base 2. Then we also have the distance between those two bases, and those two bases are connected at each of their endpoints. And so we have the length of each base, and we also have the height, which is the distance between them. And this equation gives the area for the whole trapezoid. If you're more curious about that, you can do some independent research on your own, but for this particular situation, we want to solve for b sub 1. So what we realize is that we're going to need to manipulate this equation by doing operations to both sides of our equal sign so that we isolate this variable b sub 1. Now, you'll remember, of course, our order of operations tells us that when we're evaluating an expression, we have to actually do what's inside the parentheses first. But when we're solving, we can't touch the inside of it until we've gotten rid of everything outside of it. So first we're going to have to maneuver so that we have this 1/2 and this h somehow move to the other side. And in order to do that, we're going to do the inverse operation of multiplying by 1/2, which would be multiplying by 2. So we'll multiply by 2 on both sides, and the inverse operation of multiplying by h, which would be multiplying by 1 over h, or dividing by h on both sides. So after completing those two operations to both sides of my equation, I now have b sub 1 plus b sub 2 isolated on the right side, which means I'm not multiplying it by anything anymore, right? 1/2 times 2 is 1, and h times 1 over h is 1. So this just becomes 1 times b sub 1 plus b sub 2, which is just b sub 1 plus b sub 2. And now I can isolate b sub 1 by subtracting b sub 2 on both sides. Alright, so now I've solved for b sub 1. And we want to take a second to sort of think about why this might be helpful. There are times where the variable that I'm looking to solve for is not explicitly solved for already. And so I'll have to maneuver my equation so that I can actually solve for this variable. We've done this many times already with linear equations, with quadratic equations. And we're going to do this with rational equations as well. So in this particular situation, I've manipulated my equation now so that I could find the value of b sub 1 more easily if I knew the value of the area, the height, and b sub 2, or the second base value. So depending on our situation, we'll want to maneuver our equations so that we're solving for a variable that is useful to us. And we'll continue to do this in real-world situations moving forward. A couple of key points when solving equations that involve rational expressions or rational equations. The first is something that you're very familiar with, which is that when we're solving an equation for a given variable, we're isolating that variable on one side of the equal sign. And the second is something that you've actually also done many times, which is that when we have something in the denominator and we don't want to have that denominator there anymore, we can multiply by the denominator on both sides, and that will remove that denominator that we're dealing with. In fact, this can apply if we have multiple denominators or multiple rational expressions, and through some of your discovery, we'll come up with some efficient methods for tackling rational equations that have multiple rational expressions in them. And we'll see one of those coming up in a second. So leave yourself a little space here after you've written down 1 and 2 for a couple of other key points that we'll tackle tomorrow in class. Let's go ahead and try a couple of problems now. Alright, so this is a nice example problem from physics. Go ahead and copy it down and give this a try on your own first. Work through A and B, and then we'll talk about it briefly. Maybe you'll have a couple of ideas that you can further your work, and then we'll take a look at the solution. Alright, I hope that went well. This equation is useful in fluid dynamics, meaning that it helps us model the components of a situation where water is flowing through some pipe. And just make sure you remember, pi represents the number 3.14, so on, so on, so on, so on, and so forth. But we don't want to write out all those digits, so we use that symbol, that Greek letter, to represent pi. It's not a variable, it doesn't change value. But d represents the diameter of the pipe, v represents the velocity of the water, and q represents the maximum flow of water in the pipe. So when you're thinking maximum flow, you might be asking, what is that? What does that mean? Well, flow, you can imagine if you think about your faucet in your bathtub or your sink, when water is flowing out of it, the way you might measure it is how much water is coming out, every second. And that's exactly what is meant by the maximum flow of water. How much water can come out of the pipe per second, or flow through any portion of the pipe in a given second. And it obviously depends on the diameter of the pipe and the velocity that the water is traveling. That's why this equation relates the maximum flow to that diameter of the pipe and the velocity that the water is traveling. Okay, so which variable might you want to solve for and why? Notice we've already solved for q, the maximum flow. So if we wanted to solve for the maximum flow and we knew the diameter and the velocity, we'd be in great shape. What would be another variable that you might want to solve for? Well, hopefully you've thought about this for a second or two, and you might realize, look, I know how much water I want to come out of my faucet, and I know, maybe the diameter of the pipe that I'll have. So I'd like to solve for the velocity so that I know how fast the water is going to be traveling when in fact it exits. Now that'd be kind of important, if you're filling up, a tank or something like that, you'd want to know how fast the water is going to be traveling out. So we might solve for v here. So solving this equation for v, we're going to take, you'll notice of course that v is being multiplied by d squared and pi and divided by 4. Since multiplication and division are operations that we can do interchangeably, it doesn't matter whether we take care of the pi, the d squared, or the 4 first, whichever one we choose. And so I usually like to get rid of the denominator first. So we'll multiply by 4 on both sides. Now, at this point, we know that we are multiplying v by these two things. So to isolate v, we'll need to divide by pi times d squared on both sides so that we get v by itself. You can do this one at a time if you'd like, or you can do them both at the same time. So going through, one thing to keep in mind is that when I'm multiplying, the reason I choose to multiply, for example, by 1 over pi on both sides, is that 1 over pi times pi is going to simplify to 1 over 1. Just like 4 times 1 over 4 simplified to 1 over 1 up here. And similarly, 1 over d squared times d squared will simplify to 1 as well. And then on the right side of my equation, I'm left with 4 times q times 1, and then in the denominator, pi times d squared. And of course, we remember that when we multiply rational expressions, we're just multiplying the numerators and multiplying the denominators, so we can combine all these to be 4 times q over pi times d squared. And now I've solved for the velocity. So if I wanted to find the velocity that the water would be traveling out, all I would need to find is how much water is going to be flowing out per second, and what is the diameter of the pipe going to be. So that could be very useful. All right, let's take a look at one more problem. So this last equation is actually, the form of it shows up quite often, especially when we're building equations to model real-world situations. So it's important to understand how to solve these. Now I want you to pause the video, try this first on your own. Notice the variable that you're trying to isolate and see what do you think you could do to get that variable all by itself, and have faith that if you decide that's the right thing to do, that you should do it and carry it out with full confidence. Okay, so before I show you the answer, and I want you to really take some time to work through the work that should go on here, I'm going to give you a hint or two. The first hint is that notice that instead of having just one rational expression on each side of your equation, you might on one side have more than one. So think about some skills that we've previously learned that can help you put this equation in a way that has only one rational expression on each side, so that then you can apply some of the strategies we've discussed. In about 5 seconds, I'm going to put up the correct answer. I want you to spend at least 10 to 15 minutes working through to try and figure out a method, an efficient method, for finding that correct equation. All right, here comes the answer. So here's the correct equation. Hopefully you got that. If not, go back and rework your solution, making sure that you're performing each operation correctly and that each operation is making sense as far as how it should help you get to your desired solution. There are different methods for accomplishing this end, so be prepared to take a look at a couple of different ones in class tomorrow.